Welcome to Project Info, where we learn about everything. In this episode, you will learn about the National Aeronautics and Space Administration NASA, the Canadian Space Agency CSA, and the European Space Agency ESA's James Webb Space Telescope. A very powerful, very complex space telescope. First, we will learn about why telescopes are important. Then we will learn about what is special about the James Webb. After that, we will compare the James Webb to the Hubble, and finally, we will talk about how far the James Webb will go and why go this far. Have you ever wondered why we spend thousands or millions or even billions of dollars on telescopes? Well, they are important because they let us learn about space. If not for telescopes, we would never have learned the outer planets have rings. If not for telescopes, we wouldn't have discovered the two outermost planets. If not for telescopes, we wouldn't be able to find any of the thousands of exoplanets we have found. If not for telescopes, we wouldn't have been able to see stars that formed billions of years ago. If not for telescopes, we would never have been able to see stars billions of light years away. That is 10 sextillion kilometers, 10 to the power 21 kilometers. We wouldn't have been able to find more than a couple of galaxies. We would barely have explored space. No one would have went to the moon yet. So certainly you would agree, telescopes have revolutionized our understanding of space. Did you know that the James Webb Space Telescope costs $10 billion? And it took 20 plus years to make and develop, and it will last only about 10 years. So why did they even make the James Webb? The reason it costs so much is because it is a space telescope. The reason the James Webb was built, even though it cost $10 billion and only lasts 10 years, is because it is a space telescope. So what is so special about a space telescope? Being a space telescope, it doesn't have to worry about the atmosphere. The atmosphere is a very big problem with Earth telescope. An Earth telescope will get less clear images than an equivalent space telescope because the space telescope doesn't have to deal with the atmosphere. The James Webb Space Telescope is the most powerful space telescope ever built. Okay, hang on. I know what you're thinking. So then if it is the most powerful space telescope, what can it see? Well, it was made to see baby galaxies. These galaxies are the very first galaxies ever. The designers of the James Webb hoped they could see the earliest parts of the universe. It is also made to find smaller planets. Even though the James Webb Space Telescope costs $10 billion, remember, the Hubble also cost $10 billion, then it might still be kind of worth it. What do you think? As you've learned so far, the James Webb Space Telescope, JWST, is very expensive. So why would they build it? Well, we will now compare it to the Hubble Space Telescope, another big famous space telescope. The JWST is very big. It is so big that it makes it the biggest space telescope ever built. Just the sun shield is 21.2 meters by 14.6 meters. That means its length from one end to the other is 21.2 meters. Its width is 14.6 meters. That doesn't mean it's 14.6 meters everywhere. In some areas, it is less. Its primary mirror is also huge. The Hubble Space Telescope's primary mirror is only 2.4 meters wide and weighs 818 kilograms. And guess what the JWST's mirror is? 6.5 meters wide. And it's made of 18 gold-plated individually movable hexagons. And guess what its weight is? Only 705 kilograms. That is a weight saving after increasing the size of the mirror. That calculates to that if the James Webb's mirror was the same size as the Hubble's, it would be 1/10 the weight. The mirrors are shown in comparison above. The The James Webb mirror is 6.25 times the size of Hubble's, meaning it can collect the same amount of information in 6.25 times less time. The engineers wanted to make the mirror bigger, but they couldn't, or else it wouldn't be able to launch on the Ariane 5. The composition of the mirrors is what makes the weight difference. Hubble's mirror is made of glass coated with layers of aluminium and magnesium fluoride, while James Webb's mirror is beryllium coated with gold. The reason Hubble's are magnesium and aluminium is because they reflect ultraviolet and visible light, which is what its sensors can see, while gold reflects part of the visible light and infrared light, which is what the James Webb's sensors can detect. Another feature is that the James Webb has adjustable mirrors. These let it adjust the focus. Because the Hubble didn't have that feature, they had to send a mission to fine-tune the mirror. Otherwise, they would have lost the $9 billion telescope. But because they can't send anything to the James Webb, which can carry humans, they have to make sure that it can adjust on its own. Just imagine if a $10 billion telescope was wasted just because they accidentally polished the mirror down 1/30th of a human hair too low. As you can see, the mirror of the James Webb is definitely better than the mirror of the Hubble Space Telescope, or for that matter, any public space telescope. We will be back after a quick word from our sponsor, Uranus Toilet Paper. Uranus Toilet Paper is an amazing brand that provides very good quality toilet paper. Every product they sell is tested by millions of users. Check their website for more at uranus-toiletpaper.com. Thanks to Uranus Toilet Paper for sponsoring today's episode. As you would know if you were paying attention, the James Webb is an exciting space telescope. But did you know that it is traveling to a position in space called the second Lagrange point? This is a place in the cosmos around 1.5 million kilometers away from Earth. But why would the James Webb go that far? Why, when it requires more fuel, decreasing the lifetime of the telescope? Well, the reason is the temperature and the light disturbance. So let's discuss them one reason at a time. So the first one is the temperature. The temperature is the big problem for the James Webb because it operates at just 45 degrees Kelvin, or minus 228 degrees Celsius. In space, the sun warms up the telescope. That means the farther you are, the less heat you get from the sun, which then directly translates to less weight your cooling system will have to be. That is one of the reasons why it went that far. Another reason is because the closer you are to the sun, the more light you get from the sun. This is a really big problem because the telescope's main purpose is to find the faintest objects, like early stars and planets. And if you have a huge source of light, well, dim things are hard to find, right? The telescope is just so cool. That is today's episode, and I would like to thank you for your time in watching. Look out for our next episode.